So yeah, for today, didn't really have a huge agenda at first, um, but actually some news has come up just this afternoon, mostly regarding my company. So as you know, my company, uh, Bitquill, uh, they sponsor these events, and they pay for the meetup fees and host the room and everything. So yeah, there will be some changes around that. So I want to get that out of the way first. So already we've made some changes, as you've probably noticed. Um, since we've rotated rooms ever since last month's Zoom bombing, I decided we would switch the meeting room every event, and we'd make sure that only people who have RSVP'd to the events can actually see the link. So uh, you should have all joined through that. I'm pretty sure you're all aware of that now. Um, but that's not the only change, because and I can't tell you exactly what's going on because of NDAs right now. But in the somewhat near future, we're probably going to have to switch off of Google Meet. So it's sounding like we might be using Teams. I'm not 100% sure about that. I also got an offer from the organizer of the Vancouver Web Devs meetup, and he suggested that maybe um, he could, give us a Zoom meeting room that we could uh, join in and chat. So yeah, there will be changes coming. Google Meet's days are probably numbered at this point. Um, I can't tell you exactly why, but you'll find out soon enough. But yeah, so that's kind of an in progress thing right now. Um, Aside from that, I also wanted to just quickly plug this code here. So Rust Lab 2022 is happening on October. I think it's in like beginning of October, so it's pretty soon. Um, it's happening in Florence, Italy. We have a media partnership with them again this year, and so they asked me to, uh, post this discount code. So I post that in the chat, and if you want, you can use that to buy tickets for Rust Lab 2022 at a discount. Um, you you can buy in-person tickets, I believe, or you can also buy remote tickets. Um, but yeah, it's kind of up to you. And since the event is in Italy, they usually run the event at pretty nasty hours for Vancouver. Like well, last time I attended Rust Lab, it was at like 3 a.m. or something. So yeah, it was kind of rough on the sleep schedule. So do be prepared for that if you're willing to go. But yeah, I would highly recommend, if you're interested, check it out and use the discount code that I provided. Um, so yeah, I guess that's pretty much it for the major announcements. Hopefully, there aren't too many issues. Or actually, does anyone have any questions about anything that I just talked about before we move on? Going once, going twice. All right, cool. So yeah, we'll just carry on with the meetup today as normal. Today's a free talk day.
Something wrong with my
Oh,
device. I can't hear you.
is everything okay, Evgeny? Hello? Okay, we'll just go into our usual introductions then. So introductions are voluntary. You don't have to actually do an introduction if you don't want to. This was a popular request because some people are very tired of having to reintroduce themselves all the time. So if you want to introduce yourself, Um, you can go ahead and speak up, or you can raise your hand with the little hand raising button. But I'll just start and give a quick introduction for myself. So, hello, I'm Jonathan Louie, organizer of the Rust meetups, as if you couldn't tell by this point. And yeah, I've been working for BitQuill Technologies for the last 5 years. They're the sponsors for these events. And yeah, I've been using Rust as a hobby language for several years now, probably close to 6 years, kind of on and off, just playing around with projects. But yeah, that's pretty much it. Let's go to Jay.
Yeah. I immigrated to Canada 3 years ago, and since then, I've been training myself to be a programmer. And I'm very lucky to have landed an internship 3 weeks ago. It's a web assembly company. Now I'm writing small scripts that relays data between services. I like to learn more from more advanced programmers and peers in a meetup like this. Thank you.
Awesome, thanks. Does anyone else want to do an introduction, or should we just move on? Roman.
Hey, can you guys hear me?
Yep, we can hear
Oh,
you.
fantastic. Okay, because I don't typically use Chrome or Google Meet, so I
Oh,
was kind
okay.
of, and I'm on a Mac, so with the security settings, it's kind of like a shot in the dark to try to get something working. Yeah, so I am I work for, or I guess I'm starting a company. And that's where I'm using Rust. My background was my first language I learned in '97 was C++, then Python. I've been doing Python forever. I picked up JavaScript along the way, and then this project is mainly TypeScript slash JavaScript um, with React. So I did a bunch of that, but our infrastructure, our web crawler infrastructure is all built in Rust, and that's my primary responsibility on the team. So I've just been basically buried in Rust coding full time, uh, you know, 60 to 80 hours a week since last January. So
Oh, wow.
I wanted to kind of get involved with some group locally to kind of. I've got a lot of challenges along the way that I've encountered, and it would be really great to have a community to kind of throw some ideas up a flagpole, see if anybody salutes them as far as challenges I've had, and if anybody's come across something like that, and what's their experience been. Is there something I'm overlooking? Yeah, that's it.
All right, cool. Yeah, glad to have you. We don't have like a ton of people coming to the meetups lately because we haven't had any like presenters or speakers. But yeah, I mean, it's a free talk,
Actually,
so
I was gonna offer to present. I don't know if you guys are interested in web crawling, but I've had to do a lot of work with Fantaccini Crate, and I think I've kind of um, made like 80% of the types of different um, crawling methods that you could use with Fantaccini in terms of accessing various types of front ends and back ends, APIs, and HTML scraping as well. And so I kind of thought I would share the lessons I've learned, save you guys the pain and suffering that I've had to go through in terms of figuring out how to do various things.
yeah, no, I think that'd be a great idea.
Yeah, it would basically be like I would basically just take the challenges that I've encountered and the solutions I've come up with, and effectively a spoken gist.
Yeah, no, I think that would be a great idea. I've only ever written a web crawler in Scala, and it was like a really small one. So
Oh,
I mean,
I
kind of,
tell you, actually, here's a funny thing. I actually was a huge fan of Golang since it came out, and I was like all over Golang.
uh-huh.
And then my partner in this project, he's the one that introduced me to Rust. And I was actually in the beginning kind of like, no, Golang, it's like so great. It's written by these, top people like Ken Thompson, and you know, and so I was kind of like really reticent. And then I read through the book, and actually that's something I could share with you guys. Anytime I'm kind of learning something, I make a cheat sheet where I summarize what I'm learning in as few pages as possible. So I actually summarize the Rust book in 2 double-sided pages, 11, 8.5 by 11, all the basic Rust concepts. Um, and I'm working on a third that is based on kind of lived experience in using Rust and all the things that the book doesn't talk about that will save you hours and days of pain and suffering to figure out, like, error handling when you don't want to build an error processing, infrastructure via um, enums. Just like how do you um, really quickly get up and running coding and just move through without really getting bogged down and dealing with things. Like, what are the tips and tricks to just like really plow through just like you would in Python or any other language? Like, Rust doesn't have to be, it's not like C++. C++ is bloody painful to get any work done. That's why I went to Python, and Python is great. You just like plow through without thinking too much about it until you get into the runtime, and then everything breaks, but it breaks during runtime. In Rust, you can still be as productive, I found, as I was in Python if you use all the various like shortcuts, where your code is not going to be like the best, and it's not going to be, something you definitely want to publish into production right away.
Right.
But you can get everything up and running, and you can test things without putting them in main. That's the other thing. Like, testing in Rust has just been, oh my God, where have you been all my life? So yeah, anyway, there's like so many things I'd love to share with you guys of my experience for the past half a year in writing this stuff. Um, and yeah, if
Yeah,
you're open to it, I'm happy to share.
yeah, no, just get in touch with me after the meetups, or maybe
Yeah,
I'll ping you.
yeah. Just ping me, and please ping me, because like I'm so buried. We're just like doing the last sort of push to launch. We've been working on this for the last 3 years, and I'm just so buried right now. So that's why I didn't propose to do it for this meetup. But I think for the next one, I should be a little bit more free.
Yeah, no, good.
So yeah,
Yeah,
thanks for listening, guys. Sorry for the rant.
no, that's fine. That's awesome actually. So our meetup, a lot of people who come to the meetups, or a lot of people who used to come to the meetups, would, they were looking for projects, from industry, to actually, hear from people who have actually worked with Rust, hear about its pain points, hear about, like, how they solved certain problems, that sort of thing, and where did Rust actually help them. And we've kind of been short on a lot of those kinds of stories. And
Oh man, can I share one right now? Like, just put something,
but
can I put a bug in your guys' ear
yeah,
and see if
either.
you guys can figure this one out? Okay, so um, most of my code is async via Tokayo.
uh
Um, Now, the problem with that is uh, basically the way the crawler uh, is built is it's a bunch of spiders, and each spider does its own crawling. And so theoretically, each spider should be on its own thread, crawling independently. So it's not really suited to the async uh, approach, which is which is green threads, but basically it's the way that it works is it's not intended for processor heavy jobs. It's intended for things that do a little bit of work and then wait. And while it's waiting, something else can do a little bit of work, so on and so forth. So it's more for waiting things, tasks that are wait heavy as opposed to process heavy. Whereas my stuff is process heavy. There's not that much waiting. And so I was trying to figure out here, and so all to say, here's the question: how do you in Rust take some async code and have it run in parallel? Like, how do you take two async functions and have them actually run in parallel so that they're both running at the same time on like two separate threads? That's kind of the thing I'm trying to figure out right now. Because effectively, the way it is right now, my code kind of ends up running sequentially.
Right. Yeah. That would make sense because async isn't trying to use multiple threads.
Well, async is for waiting. It's like if you've got something that does a lot of waiting and processing in between waiting, that's async. If you have a lot of processing with a little bit of waiting.
Hi,
then,
Roman. I have some speculations.
Yeah.
There is parallelism and there is async.
Yeah, concurrency.
You are saying that web crawling also consumes quite some computing power. So you need the ability of running your program in an async fashion, and you also rely on parallelism to compute. I vaguely remember that there are different flavors of async. There are flavors like Tokyo that put emphasis on handling many tasks at the same time. So both parallelism and handling lots of things together. And there are also approach which is to focus more on the parallelism to handle more compute-heavy tasks. I wonder if you're able to find choices like that.
So the thing about the whole async environment in Rust right now is that it's based on these runtimes, like Tokayo is a runtime, right? There's also Futures runtime, and like most of the code, most of the other crates, like Fantaccini, the web scraping library, it's async. So I have to. So my code is async,
right.
but I have to be able to basically launch two async functions at the same time and have them work in parallel in almost separate Tokayo runtimes. Because the whole thing is like it's this is where it's really tricky, is I'm mixing up, because Tokayo has its own, the way it works is with thread pools. So it's got multi-threading built in. But anyway, so Jay, you're kind of on the right track, but I'm kind of really looking for like, has anybody encountered something like that, and how did they address it in Rust, and preferably in Tokayo? And actually, Michael Wu in the comments, in the messages, mentioned Tokayo spawn blocking, which is something that I've been investigating. So I guess I'll dive deeper into that, maybe investigate that a bit more. I'll let you guys know what I find because that's a really complicated area in Rust.
Mhm.
I've found personally is just dealing with, how do you mix, like I've kind of avoided the whole async, deep dive in Rust so far.
Okay, I see.
I've just kind of like, it's like, oh, okay, this is async. Okay, I'll await. Great, move on.
Yeah.
But I haven't like looked at, like, I knew this was going to be an issue down the road, and I'm kind of at, getting to that point on the road. And so I'm kind of now starting to research what the best approach is for,
I'm afraid I'm in the
yeah,
similar boat. I've mostly just
yeah,
if I'm in an async function, I just kind of await things, and
yeah.
it works, and that's
You
great.
know,
It's not.
actually, I've got a I've got a guy from Norway who wrote a very awesome bunch of articles on parallelism and async in Rust and kind of how it works, and like it's super crazy. I actually offered to partner with him to actually put together an async and concurrency versus parallelism in Rust book based on his articles. I wonder. I'll ask if he might be interested in doing like a little presentation. I'm not sure, but that's something I'm really interested in exploring with you guys. And
Yeah,
I
I
think,
would love to learn more. Yeah,
yeah,
that's awesome.
yeah, it's pretty crazy.
I'm wondering if this isn't something that would be solved more easily with the new the upcoming keyword generics, where you're allowed to like define a function and it can be both. You can use it in synchronous context and in asynchronous context, so it's not just like once you're in async land, you're kind of just like stuck there forever, kind of.
Yeah, yeah, and that's where what Michael mentioned, which is the Tokayo blocking, spawn blocking. That's kind of, I think, from my initial research, a way to escape out of the async world and get a sync function, I guess, or a sync type. But
Yeah,
I'm still experimenting on my end. Like I'm still experimenting.
cool. Yeah, I mean, if you can get him to also do a talk, that would be amazing.
Right? Yeah.
Yeah, more talks are definitely welcome here. So
Yeah. Yeah. I gotta reconnect with him.
okay, cool.
But there's some good stuff in the messages I'm just reading from everybody.
Yeah, I was also gonna suggest Maple
Michael and Evgeny.
because Rayon I know is used in a lot of
Yeah, I use Rayon actually. Rayon is great. I
Mhm.
use it for a few of my like type conversions where I go from one type to another, but like on a big data set. And so I do parallel iter on that. So that works really awesome. I think on one of them, I had a data set of like 10,000 records. And initially it took like a minute and a half. And with parallel iter from Rayon, it ended up taking like 30 seconds. And then once your cache is warmed up, then it takes no time. So Rayon is great.
Mhm. Does anyone else have any I guess introductions that they want to do, or just before we get too sidetracked? I mean, I guess we've already kind of gone on a tangent, but I'm gonna take that as a no. Okay, everybody else is good. They don't want to introduce themselves. That's fine. Um. So yeah, I mean, yeah, I know you have Evgeny. That's why we switched to the voluntary system. So yeah, today's a free discussion day. I do have a few news articles that I picked out. Thanks, Peter. Have a good day. Thanks for coming. So yeah, I'll just quickly go over some of the news articles that I picked out this month, and then we can just open the floor for free discussion. So I'm going to share my screen. So the first one that I have here is actually this really neat video. So if I don't know how many people are into like video games or game development or Minecraft, but yeah, someone it's been it's been a bit of a long running joke, like one day they'll run Minecraft in Minecraft kind of thing because they have this, they have these like redstone circuits and stuff that can kind of be used to implement your own like computers in Minecraft, and so uh, finally someone actually kind of did it. I mean, it doesn't look exactly like Minecraft, but it's but it plays pretty similarly. Like they've implemented some of like the core functionality of the game, which I thought was kind of neat. And yeah, it turns out that the server for this was actually written in Rust, and so yeah, this was kind of a really big deal for like the Minecraft community. What's kind of funny is that on the Minecraft subreddit, they actually deleted the post because they they linked to the their server so that if you want to learn more about it, you can go join it, and that counts as advertising. So yeah, it like blew up, and then the mods decided, hey, we're gonna just delete this. No problem, right? So yeah, that was there was a bit of controversy around that, but the Minecraft mods seem to be very very strict about their rules, and they aren't they're not reversing their decision. So the other stories here are a little bit more about like I don't know, the kind of stuff that you would expect to see on like the front page of like Hacker News or whatever. But I decided might as well go over it anyway. So yeah, Rust is going to be making it into the Linux kernel after all. I mean, we've had plenty of these articles pop up over the last few years or so, and they've been talking about, oh yeah, Rust will probably make it into the Linux kernel sometime soon. No idea when, and now it seems like it's actually finally happening. So that's it's pretty cool. I mean, I had coworkers of mine who literally know nothing about Rust and don't even use Rust linking me this article. So apparently it kind of blew up. But yeah, um, seems like a really good this seems really good for Rust, obviously, because now that it's being used by Linus Torvalds, it's kind of going to give it a little bit more of a boost in popularity, I'm sure. But I've also seen some skepticism about this too, mostly around how long it might stay in the Linux kernel, because supposedly they've tried introducing C++ uh, in this space before, and it lasted for like a few months, and then they got rid of it. So yeah, well, I'd say like if you're really hoping for Rust to be in the Linux kernel, um, don't celebrate too early because they could still back out of this decision if they want to.
Just one thing about the C++ and the Linux kernel. I do believe I recall that Linus is actually incredibly hateful of C++ to begin with.
Yeah,
I think that was maybe pushed by members of his of the community, and
right.
he finally caved. But then once it was introduced, and he tried to like review the code, he blew a gasket and pulled a Trovald. So I don't know. I think with Rust it'll be different. I don't know. It's
Yeah, I mean, he hasn't had like glowing praise for us as far as I know, but he hasn't said it's like awful or anything. Like he seems okay with it. So
he's been Rust curious,
yeah,
which
that's
is good.
a good way to put it.
Yeah.
Yeah. So yeah, I mean, I'm glad he's like giving it a shot, and we're gonna, be able to see, uh, Rust in more mainstream projects and get a better feel for the language and how it performs in those kinds of scenarios. Um, 'Cause, yeah, I'm really interested in seeing like, will this project actually be a success, or will they just end up having to scrap it after all, and for what reasons, that kind of thing. So yeah, there's that.
It's a good approach. They're only so the thing about the Rust in Linux is, to be clear, it's for writing drivers.
Yeah,
It's limited to drivers, which is a really great approach. So it doesn't really impact uh, Linus and the kernel work, because these are separate modules that are kind of not really impacting any of his core kernel code review. So I'd be really surprised if it's I think what it is, it's mainly an introduction of Rust into the kernel workflow, where
Mhm.
you can introduce these Rust modules and they can compile right away without you having to install additional tooling. That's my understanding of. I just wanted to share a link with you guys on that. It's an article discussing how to write drivers for Linux in Rust. So just put that in the messages.
Oh wow, that's very interesting. Cool. Um, let's see. I see there's some activity here. No, not too much activity, but oh, here's another article from Michael. Ah, yes. The ever ongoing discussion about, can Rust match C's performance? Yeah,
It depends. How do they calculate performance? Do they include all the human hours spent on tracking down security flaws on the back end
yeah, that's
after the code's released, or is that just to how much how
no concrete answer, right? Like, on the one hand, you've got these little like micro benchmarks and like the benchmarking games and stuff where people are writing like super highly optimized code that isn't necessarily very readable, isn't necessarily what you would write, on your day to day, and they're showing like C is actually faster than Rust. Um, but you also see a lot of other projects. There was one that I saw not that long ago. I can't remember what the name was, but it was showing that Rust can be, just as fast as C, or if not faster, in real world projects where, on both sides you're just kind of writing code in the very idiomatic, typical fashion. So it's sort of difficult to really gauge like which is actually faster, and it kind of goes case by case and depends on who wrote the code and how optimized is it, how readable is it. So I don't know. It for me it's sort of nebulous. I just think they're comparable. And you just need to do the benchmarking yourself. You got to profile your code and figure out
which
what's
one?
for you, right?
Yeah, that's the better question. Which one would you choose to write in 2022? And for me,
Yeah.
it's like a no-brainer. Like I do not want to deal with malloc at
God.
all, at all.
I've
I'm
shot
so
myself,
happy with Rust.
but just with C++ alone.
Guys, I have some comments to make. What we are talking here really don't count to the kernel community. They have been working with C for decades, and they are the real pros, and they control the high stake projects. So what we're doing is just chatter. Don't matter.
Oh yeah, no, of course, but I mean, it is what it is. I mean, there's a lot of C and C++ out there already. Same story with like Java and even COBOL, right? Like these projects are written in C and C++ or whatever, and no matter what comes out afterwards, they're probably never going to switch off of what they're currently written in because the cost is just too high.
Actually, on that regard, there's a really good example recently of a company that has a huge code base in C++ and them actually switching to Rust. Autodesk. Autodesk is in the process of kind of doing a transition to Rust.
I feel like I heard
Um,
about this like a few
yeah,
years ago.
yeah, they did a web-based interface for their CAD using WebAssembly.
Yeah.
And basically, their approach was, they're not going to get rid of the C++ code, but they're going to like add to it via Rust by using an ABI. And that's kind of where they had a lot of successes, where rather than replacing the Rust code, they just um, basically created a way to interact with it from Rust. And Rust makes it, relatively easy to do that.
Hmm. I mean, nowadays they're talking about stuff like Carbon. I think Herb Sutter is talking about his own ideas for like a successor to C++, where these newer languages will have better interop with C++. So, I mean, I don't know. Like Rust might be used in those kinds of projects right now, but in the future it could be phased out by like Carbon, right? So it's kind of hard to say. On that note, the last story here is probably one that you've seen. It's this tweet from Mark Rusinovich. I don't know how to pronounce that, but yeah, he was saying, it's time to start halting projects in or new projects in C and C++ and use Rust for those scenarios where a non-GC language is required. And so if you don't know, he's the CTO of Microsoft Azure, and apparently he also wrote sysinternals. Um, and yeah, I mean, it's an interesting take because obviously I think there's still a lot of cases where you probably can't use Rust. Maybe it just isn't supported well enough on whatever platform you're using or whatever you're targeting. But I mean, it also still has its share of rough edges too, right? With like async right now, and um, there are a few other things I can't think of off the top of my head right now. But yeah,
Can I offer one?
Go ahead.
One that's been really painful is the having to wrap types because you can't. It's the whole. I forgot what it's called. Sorry.
The new type pattern, or
No, it's like where if you want to expand on a type, like if you want to add another, like for instance, if you're working with, a type like string, and you want to add another trait to it, or sorry, another method to an existing trait. You can't do that right now in Rust outside of the package. It's the what the heck is it called? I forgot. Sorry, but where you basically right now you have to wrap. Like okay, I'll give you an example. Okay, hash map. You can't just add another method to a hash map, like your own custom method. You have to take the hash map and you have to wrap it in a struct, in a like just a tuple struct, and then you can write methods on that tuple struct.
really? Because
Yeah,
I'm able to add methods to like int, or like it's not int, but like a U32 and other primitives. So I imagine you would be able to do the same thing for like a hash map as well, just by defining your own trait. Or do you mean like implementing a third party trait on hash map? because
Yeah, so
that's a different.
so you can implement a third-party trait, I think, on the you're right about that. Yeah, you're right. Sorry. No, I have an example. It's just I can't. I need to think about how to. It's there's an RFC for it, and it's really big. I'll look it up and I'll share it with you guys.
Okay, yeah, because it sounds to me like maybe they're trying to relax orphan rules a bit.
That's what it is. That's it.
Yeah,
Sorry. Yeah,
yeah.
orphan rule. That's the one.
If you want to if you want to add your own methods to HashMap, you can. You just have to
Yeah.
define it within your own crate. But
Yeah.
the restrictions are around if you try to implement a third-party trait on a third-party type, that
Yeah.
everything breaks down.
Yeah.
Yeah, I haven't been following any RFCs or any news around that recently. So yeah, I'd be kind of curious to know like what the plans are around that, because that has bitten me in the past too.
Not only you. That's actually it's when it first bit me. I did a little bit of a deep dive into it,
Mhm.
just to kind of find out, where are we at with that. And actually, I don't know if you know this, but I found this really interesting that actually a lot of the problems that Rust currently has with async and all these runtimes not being able to interoperate with each other. Like if you have some code that's written for the Tokayo runtime, you
Mhm.
can't use a different runtime with it typically.
Oh yeah, no, a long
Right?
problem. The
Yeah,
previous
but
organizer
that's
of this meetup would complain about that incessantly.
yeah, and the thing I discovered was, and I don't know, maybe I'm just not that bright, but um, the orphan rule is actually the root cause of that.
Interesting.
And as soon as they're able to figure out the orphan rule, they're going to be able to completely unify all the runtimes for async and Rust, which I thought was like incredible.
Interesting. Yeah, I thought they just have like some sort of interface for like, over the runtimes somehow, and that would work. But yeah, I'm not really sure. I'm not up to speed with all that. Um, the orphan rules are there for a good reason, because if you've ever I might be out of my depth here, but I know in Haskell you're allowed to have like orphan instances of type classes, and that can lead to problems with like um, compatibility. So
Oh,
it
I totally agree. No, orphan rule is very important. I think from my read of the RFC is it's just a implementation question. Like how do they implement the solution without
yeah.
without breaking it? Like
Mm.
they don't, and the sense I have in the community, nobody actually wants to break the orphan rule. They're just looking for a way to kind of work better with it.
Yeah, because right now it's a little too restrictive, and there aren't a lot of ways of really easily dealing with it. That's true. I mean, a lot of people suggest new type, but new type only gets you so far sometimes.
Yeah, and that's kind of the solution I've had to do is I've had to just basically an example is like um, for vector, I think. Um, right. Yeah. So like when I do when I do a type conversion, I take a vector, for instance, in like try from for type conversion. So I'll implement the try from. I can't implement the try from on vector. I have to wrap vector inside of a tuple struct
Yeah.
to create a new type. And that's just annoying, but it's like it's not the end of the world. It's just a little bit annoying.
I mean, new type pattern is, yeah, it is kind of it does cause you to have to go through a little bit of extra pain than
Yeah. It
the
it it also kind of makes your code look it's just odd because like throughout my code you'll find all these references to tuple vec. It's like
yeah.
what the hell is a tuple vec? It's just a wrapper around a vector. That's it. It's like why are you doing that?
Well,
Rust.
the thing is, it's not that. So, like from a boilerplate perspective, like yeah, that's annoying, and it's something that might be solved if we eventually ever get delegation or something. There is an RFC for that as well, but it's deprioritized. But like the new type itself isn't that bad because it's a zero cost wrapper. It doesn't actually add any overhead. So like,
Yeah, I totally agree. It's just a visual thing when
yeah,
you're reading code. It's
well,
just odd.
yeah, and the name. Yeah, the Rust type system isn't as strong as it could be. Um,
It'll get there.
I don't want
It's got good bones.
to. I mean, I kind of hate to say it, but I don't think it ever will get there. I mean, it's improving. No, no, don't get me wrong. It's improving. I mean, we're getting stuff like const generics, which is definitely helping out with a lot of some of these rough edges as well. But there are certain things that Rust will probably never have, like algebraic effects are never going to land in Rust because they've gone with keyword generics instead. We're probably never going to see like actual full-on dependent typing in Rust. Const generics is probably the upper limit of what they're going to implement in Rust, realistically. We'll probably never see like real like the quantitative type theory, like multiplicity annotations or anything. Like we kind of have linearity right now with the way that ownership works, but ownership and linear semantics are kind of they are kind of different. So you're not going to be able to specify. You have to use this variable exactly 2 times or stuff like that, like what they've done with Granule with its graded modal dependent types. So there's a lot that Rust could do potentially, but will probably never do. And I think part of that is just because when it was created and the state of the art at the time, and some of these things we haven't been really like completely figured out in terms of like runtime overhead. Like no one's figured out a way to do certain things completely zero cost. I mean that's one of the reasons why we don't have higher kinded types in Rust. They could have done like the monad thing, right? But there's a cost to that, and they decided they just couldn't do it. So. Speaking of types, yeah, as Michael says, it seems like GATs are going to Rust stable soon, which is kind of interesting. You can emulate monads with GATs, which is I don't know why you would, but I mean you could do that. Um, yeah, I'm kind of excited for it, but I also don't really have like a ton of use cases for it in my projects right now. So yeah, I'm definitely glad for the people who do need it. And it should make some of the existing like standard library implementations faster as well. I think like reading from files should be a little bit more efficient with GATs, if I understand correctly, because of the streaming iterators being possible. Um, yeah, I don't really have anything else I want to really chat about today. So if anyone else has anything that they want to talk about, then yeah, go ahead, be my guest.
Yeah, as I have shared with you guys, I have joined a web assembly company for internship. I'm new to this, so I want to gather more knowledge. My impression is that uh, it's the popular runtimes like Wasm Time, like Wasm Edge, are still not mature, and the uh, there are many quirky things with those implementations. Uh, I just want to I want to know you guys' idea or impression about where WASM is going, how fast things are happening.
I honestly don't know. I don't follow WebAssembly, and but I do know some people who absolutely hate it and they don't think it's going to solve anything. But yeah, they're part of the browser should just be a window crowd. Let's just say.
Jay, are you asking about the implementations and crates in Rust for implementing WASM? Is that your question, or are you asking a question about the future of WASM language independent.
I want to I'm doing a poll among these 5 people.
Yeah.
So do you feel that WASM is taking off? And have you had any exposure to WASM? Do you feel it ergonomic enough to have your hands on, or you're still waiting?
Right. So I've had like a few little dives into looking into WASM, because one of our things that we have to implement is it's a like a chart, and a data chart, and it has a lot of data points, like thousands of data points represented, and it has to be able to update quickly and all of this other stuff. And so I've actually been pushing for implementing it in WASM as opposed to TypeScript with like SVGs. And so that's where I kind of did a little bit of a dive into, how does WASM look? I mean, do you guys remember sodium chloride, or NaCl, from Google?
I
This
don't.
was like 2006, 2008, something like that. So Google had released back in like 2006 to 2008. I don't know if I have the time period right, but if you look up NaCl, it was basically a in-browser like highly efficient app implementation. Like I think the example they did was they actually implemented Quake in NaCl, and that was kind of like to show off that it is possible to have the browser work as a sandbox for for an app that is the same speed as native code on your operating system. And that's just to do with these, software as a service crowd. And I don't think it's going anywhere. I think it's just going to get more complicated. Like if you look at companies like, what's that one? Sorry, I'm like, maybe it's the end of the day. It's hard to remember stuff. But there's a lot of companies that work with big data, and they do rely on, like, browsers to deliver their user interfaces. And so, I don't think it's going anywhere. I think, it's a problem that's existed for a long time. There's been a few attempts to fix it. The first one, as I mentioned, was the NaCl attempt by Google. It didn't go anywhere. And WebAssembly, it looks like a lot of people are grabbing onto it and, just running with it. So, like I said, when I heard Autodesk say that they're fully behind WebAssembly, that's big. Like when big companies like that jump on board, that gives it a huge momentum push. That's not going to allow it to slow down and die easily. So I don't know. That's just my thoughts.
Yeah, from what I've heard, and I'm not very well informed at all, so don't take don't take what I say with a grain of salt. But from what I've heard is about WebAssembly is that it's not as performant as it could be, and it still has like some dependencies on JavaScript, so you're not really getting rid of JavaScript at all. And I don't know. I guess from the perspective of people who just hate JavaScript and want to get rid of it, that kind of sucks. But it's like an improvement, but it doesn't take it far enough from what I've heard. But yeah, I don't really know too much.
I have a question related to what I've just talked about. Nowadays, it's very popular to use a cloud service like Netlify, Vercel, Fastly, and they have wrapped up their code base in their services, making it much easier for average developers to deliver something presentable with low code, with minimal amount of code. What's your do you have any hands-on experience with similar things? Well, what's your observations?
On like no code or like low code?
The focus is not low code or no code, just delivering software as services and enabling developers to put something together quickly.
I mean, I think we all want to be able to put stuff together quickly. I guess I don't really have enough context for this, but
the easiest example is those services enabling making of a website. If you want to build an advertising-centric website, you want to build a e-commerce-centric website,
right.
they have templates, and you can.
You mean like Squarespace type sites, or?
I don't know much about Squarespace. It should be similar, like Wix. Like
Wix. I've used Wix. Yeah, I had to use that for a course once because it wasn't a computer science course, that's why. But they wanted us to put together a site, and they knew that most people in the class weren't programmers, and so they made us put together the site in Wix. I don't know, like I've seen a lot of those tools for years now, and people still seem to not really stick with them that much. I mean, some people, have used them to great success, and for other people, it's just it doesn't allow you to do everything that you want to do. I think, and for yet other people, it's you're not really developing the skills that you want to develop. If you're like looking for a job or something, so yeah, it just kind of depends, I guess, on what your use case is and what you're doing. If how complicated is it? Otherwise, I don't really have like a strong opinion like for or against those sites, or yeah, or those services.
thank you.
I actually have a question. It's something I've been kind of wondering about, is about the Rust runtime, because we know a lot of people on like Reddit and other sites will say that Rust doesn't have a runtime, but that isn't true as far as I know. Like they have a page for it in the book, and my understanding is that it's packaged in like um, every single binary, every single Rust binary. Um, but I was wondering, like, does marking your project no standard affect that, or what? Because some people are saying like the runtime of C is libc, and so like the runtime of Rust would be like lib standard. But like, I'm just kind of dipping my toes in this area, and I don't really have like a full picture yet. So I'm wondering if anyone understands that or knows more.
I don't know too much about it, but I do know that there's a big movement happening in the area of embedded Rust. And if you look up info on embedded Rust, they've got a ton of resources
Yeah,
on dealing with that.
doing. I actually went and ordered this board because of the Rust embedded book. It's part of the learning exercise there. But I think I haven't gotten deep enough into it to understand this stuff. So that's kind of why I've actually been asking. But
It's
yeah,
a bit of an esoteric field. I don't think there's been too much like it kind of goes back to the point raised earlier that Rust isn't implemented on so many types of hardware.
yeah.
So it's still early going.
I'm some speculations again. When Rust programs are compiled on different, targeting different operating systems or different platforms, those system level things have already been packaged into it, right? So if a Rust program is to run on Linux, so the Rust program will be able to talk to Linux OS to get memory allocated by the OS and passing messages. And if a Rust program is compiled on bare metal, so the program will carry lots of functionalities that will handle memory management. And so it's going to work without an operating system. So then going back to your question. So is there a question?
Sorry?
So I'm saying that there's no question. Rust programs can be compiled to run on an operating system. It can be compiled to run on bare metal.
Yeah,
And, yeah.
But I'm just because like the Rust runtime has like a panic handler and stuff. I guess I don't know. Like I was just kind of confused because some people say that libc is a runtime and for C, and lib standard is a runtime for Rust. But I feel like if you have a no standard project, that mean that you wouldn't have a runtime anymore? But then it has to have like a panic handler and stuff still, right? Like I think there would still have to be some kind of like minimal runtime. I don't understand. Like maybe these are like conflicting definitions of runtime, but for me it's a little bit confusing. Like what people mean by that.
For Tokyo, it has runtime because a async multi-threading program needs more services from the operating system than the
I mean, I'm not
native thread.
async. I'm not even talking about async. I mean, like just I think there's a page on this. If you look up like Rust runtime, it's in like the official documentation. They talk about like it has like facilities for unwinding on panics and stuff, and being able to return um, uh, ithers from or sorry results from main, right?
If I may just interject, my understanding is like libc, and like Windows has its own lib. These are all just libraries. They're not runtimes. They're just libraries to interact with the OS.
God. Yeah. Well, some people say C has a runtime, and then they point out libc as a runtime. I'm just like,
No, I mean, like, okay, I think if you take a very liberal view of what a runtime is, you could say, yes, libc is a runtime, but is then the operating system a runtime? Well, yeah, it is a runtime. So it's like it turns into Russian dolls, nesting dolls, where it's like your runtime is in a runtime is in a runtime is in a runtime. It's
okay.
like, I don't know, like I think what you're asking about is specific to embedded. Um,
Hmm.
so I feel like in your case, like you can't rely on libc unless your microcontroller runs libc, like unless your microcontroller uses the Linux kernel,
Right, okay.
right? So like so that's where, like, and I'm an amateur when it comes to this. So like, please, don't take my word as kind of like the thoughts of someone who knows what they're talking about rather than ramblings of an amateur. Um, but like I think about it in terms of, how would it look if I was writing it um, in assembly, right? Like
Mhm.
for a microcontroller, I would be making calls to the various registers, right, and have it do whatever it's doing, um, to achieve the end result. So like, is my app the runtime, or is the microcontroller interface to the registries the runtime? And so with Rust, if you're working on a microcontroller, like what you may have is you may have what you could call a runtime from the microcontroller manufacturer, right? Where it's the interface for, so you don't have to call individual registers, right? Because at the end of the day, it does have to talk to individual registers. It ends up as assembly at the end of the day, right?
Allow me to jump in.
Yeah, please.
Let's time travel back 50 years. And computers at that time didn't
Hold
have
on, I got
operating.
whiplash. We went too fast. We jumped too far back too fast.
At that
50 years.
time,
What year is that? Is that 80? 1980?
at that time, computers didn't. I wasn't exact. At that time, computers didn't have operating system, so scientists have developed special purpose programs, and they are to run on specific hardware. And why we have created operating system? Because we wanted to be a general purpose computing device. So with operating system, the operating system can manage system resources. So generic programs can run on them. Then fast forward 20, 30 years, operating system can do a lot more. And it's going to support many different runtimes. So like the Qt graphic GUI system have a runtime. The Unreal Engine have a runtime. And so on top of operating system, those runtime provide additional resources to support specific programs to run on top of them. And going back to Jonathan's question, so generic Rust programs, do they really need more than system resources, additional runtime, other than async multi-threading? They need something. They need additional support in managing threads. So
I think I agree for the most part what Jay said, but it's I mean, like it's like the runtime in your question. Your question is STD, Rust STD a runtime?
Yeah.
And I would say no, because it gets compiled into your code, and then you interact with libc, for instance, outside of your code if you're running in Linux, and you'll interact with something else as an API.
Oh, okay, I get it. So I guess like the standard library or like lib standard is not comparable to like libc, even though
No, I
same.
mean, like, no, they're not. No, no. I mean, libc is just a. I mean, libc is a collection of helper functions to help you interact with the operating system in a standardized way. Like, for instance, if you want to call up a thread, right? If you want
Right.
your own thread, you would do that through libc, because libc has all the interfaces to the operating system. In Mac OS, it's something else. It's not. I don't think it's libc. In Windows, it's something else, and that's kind of. But if we want to jump back to what Jay was saying, like back then, I remember reading or hearing about. I'm not that old to remember what actually happened, but what I remember reading about is like the challenge they had back then was anytime a language was developed, their challenge was to create compilers for every architecture, to get them to work in those architectures. And then, without operating systems, like that's all you have. But with operating systems, it made it a lot easier to write compilers. And then today, we've got LLVM, which is what Rust is built on. So that's how they're able to support so many architectures right out of the gate, because LLVM supports architectures before Rust came along. And so that's kind of where, you know, that's where I would say like the no STD for your microcontroller is related to the fact that the STD library may not be able to interact with your controller.
Hmm.
Like it's kind of useless for that. But there may be other functions in the STD library that aren't interacting with the OS or whatever runtime, like libc or whatever, if you want to call it a runtime. So what I would say, I guess, is like for your microcontroller, is there a library that the creator of the microcontroller issues as the kind of interface for interacting with all the functionality?
Right. Okay.
Yeah, I mentioned earlier the Qt GUI system. They have a runtime. So you install the runtime on top of bare metal, and then you run your Qt program on it.
Right. And is that more like like the async runtimes? Like it's a like because that's a library too, right? Like they're the standard like the regular Rust runtime that handles like panics and stuff like that, and generates other like platform specific code. And then my understanding is that you can async Rust, you supply like a library as like a runtime specifically for like async operations. So the whole idea of like runtime, like what the definition of runtime is just it feels very fuzzy.
I mean, to me, a runtime is like something that manages memory and resources of the operating system, that allows you to interact with it. Sorry, and interact with operating system resources.
Okay, fair enough.
And for
In a
a
dynamic way. Sorry.
for a scripting language like C#, like JavaScript, they need runtime to provide functionalities. It's more than providing the computing resources. That's my understanding.
Yeah, like the Java runtime, but that's a whole like that's a whole big, you know, complicated, convoluted mess of it does so many things. Um, that's a really complicated example. I don't know what's a simple runtime that you guys have run into. What's like the simplest runtime you've encountered? Like Tokayo is a runtime. If we stick to that example, all it's doing is it's managing the thread pool. It's running in the background. You're making calls to it, and it talks to the operating system and says, "Hey, I need another thread because there's this task that I need to assign to it." So your software is not doing that. But you could do it manually and and then you end up with a runtime in your software.
Yeah,
It's
there is a wording like batteries included. So
yeah,
I can
yeah,
say that runtime here provides batteries.
Yeah, I mean, but there's a page in the Rust documentation that literally, has it talks about a runtime. I just linked it in the chat. So like there are batteries included there, right? But it's not doing like garbage collection or anything like that. So
yeah, and that's where you get into like the simple runtimes or complicated runtimes.
okay, so like Rust would be a simple runtime, and I guess like
JVM is like a ridiculously complicated runtime
right. Okay.
because like LLVM is a runtime. It's a like it's a
Uh,
virtual machine.
is LLVM a parser? It's a runtime.
Well,
I don't know.
it's a parser, but it's also a runtime. I mean, It depends, I guess, how you use it. I don't know enough about LLVM to.
So there's like layers of runtimes then. 'Cause
Yeah,
Rust,
Russian nesting dolls.
runtime, and then if LLVM is a runtime, then yeah.
Yeah,
All right, so I guess that's why there's people who just say there's no everything has a runtime. There's no such thing as it doesn't have a runtime.
and that's where like the whole question about libc, is libc a runtime? It's like,
Mhm.
well, maybe. And I guess that's why there's no straightforward answer. It's like the operating system is a runtime, and libc is like your door to be able to talk to the operating system.
Right.
So which ones wouldn't how can you separate the two? I guess you could, but libc is not running in the background managing thread pools and stuff. The operating system is doing that. libc is just giving you a bunch of it's literally in the name, libc, library, C library. So it's just a library. So is now every library a runtime?
Yeah, that God,
I
this
mean,
is so confusing. I can't believe.
yeah, it's honestly, that's where I just go back to how would it look in assembly
Uh-huh.
if I'm and to specific to your question, because otherwise we get into this esoteric world of runtime debates. What's a runtime? What's a library?
Yeah.
Um,
Jonathan, so if you're able to discover the thing, well, what are you trying to do?
that's a good question, Jay. We should have probably asked that at the beginning.
Oh. No,
I mean, you showed a microcontroller you're trying to interact with, right?
yeah, I mean, I was just kind of confused because I was just reading some posts and people were saying stuff like that. There is no runtime, there is a runtime, and I mean, I was just kind of confused because I was gonna try and I looked into the that page, the Rust runtime page I just linked, and you know, I did some more digging around, looking at blog posts from like Manish Earth and some other people, and trying to figure out like what exactly does this do, and it seems like it generates some code. I was gonna try and disassemble like the binary for like a project that has the standard library in it and one that doesn't, and see like does it still have the runtime in there. Like I was just very confused, like what is the runtime. But now that I understand what libc is, I think that the confusion is gone, because I thought libc was like sort of like the standard library of C or something, where as opposed to like the standard library in Rust. I wasn't really like doing anything in particular.
I
Is like
think my understanding of the standard library in Rust, what its purpose is to basically what's in the name, standard. It's a library of standards. So it's a way for Rust where you take a function like panic, and in any software you write, you can write panic, and you'll get the same behavior. It doesn't matter if you're running it on Raspberry Pi, on Linux, on Mac OS, or on Windows. You're going to get the same result. Why? Because in standard library, when you call panic, it first figures out, well, when you compile, actually, it's like simpler than that. When you compile your code and you pick an architecture, the standard library will pick out the code that is specific to that architecture. Because the standard library, have you looked at the standard library, to see what's actually in there? Like for panic, if you look up the code for panic, what's in the standard library?
actually don't know.
Because then you'll see exactly, what is it that the standard library is doing. My understanding is the standard library is just a generic wrapper around all the various system calls on all the various operating systems for the same thing. Like on Linux, you call to libc and there's a specific system call for panic on libc. In Mac OS, it's a completely different system call. On Windows, again, completely different system call. And so with the way to avoid having to know how you have to write each individual system call on each system from Rust, they just generalized it. And they said, you know what, don't worry about it. Like this doesn't change every year. We'll deal with it. Here's a simple Rust function you can call and you'll get the right behavior. Just call panic. We'll figure out what the actual system call should be on the system you compiled your code for. Does that make sense?
I think so. So like the actual, right, because there's
like on Windows, the call is like it's this really crazy call to the Windows API. As with all things Windows, it's like super complicated, and it's actually in C++.
right.
And so what the Rust standard library does it actually interacts with C++, and it does the C++ function calls
But
to
only
initiate a panic.
but only on Windows, right?
Only on Windows, yeah. On Linux, it calls the libc panic function, which is really simple.
Uh-huh.
It's just one simple function. I think in Windows you like have to initialize something, and then you have to like scaffold something else, and then you have to send a sig to some function, and then in the end you get a panic in Windows.
Mhm.
In Linux, it's like call fn function with some args. Done.
Okay.
And in Mac OS, it's similar. It's to Linux. It's just
Right, and but the actual panic handler is in the runtime, the Rust runtime.
so that's kind of where we get back into the confusion of like, do you really need to know if it's a runtime or not to get your controller to work?
No.
Yeah, so like don't even think about it. Like who cares? Forget it.
Yeah.
Like
Well, I mean, actually, the reason this came up in the first place was I was chatting with a coworker, and they were very skeptical about Rust, and they're saying, well, you have to deal with like like isn't Rust a bit slower than C because you also have to deal with the Rust runtime kind of thing. Uh, Like
geez, what is this guy doing? Is he building a high frequency trading computer that's like, why does he need this crazy speed? Like, my reason to choose Rust was never about the speed. The speed was like a nice to have. Like, okay, great, I can optimize. Like, geez, if you really want speed, you will write inline assembly in Rust, and then you're faster than, like you're as fast as C because C is just syntactic sugar over assembly at the end of the day.
Well, yeah, that's true. I mean, there's
Right?
an article saying, like C is not a low-level language, and yeah, like I kind of vaguely got the gist of that.
I'll tell you, like the reason I love writing in Rust, and I actually did a major release yesterday for my crawler, and I have to now start writing in TypeScript, uh, like this week. I have to go back to writing TypeScript, and I really don't want to because Rust is just so like the tooling and everything is just so. It's like I was gonna use this analogy. Um, do you guys remember the '90s Apple? Apple in the '90s, like early to late '90s, before the iMac, before all of that, like before it became really like big. Like iMac, like the Mac back then, the Apple back then, it was like the Apple users, like you could see an Apple user from across the room because they had that kind of like um, quiet confidence about them that they know that when they need to do something, they'll be able to do it because their computer will just get out of their way and let them get stuff done. And they don't have to fight the computer. Like Linux users these days know the pain of like, you want to do something simple. It's like, oh man, You're going to have to like fix a bunch of drivers that aren't working. You're going to have to like figure out a bunch of config files. But back then it was like that with Windows, where like, Windows is painful. With Mac, it just works. You don't have to deal with any like, crap. And I feel like that's the case with Rust today. As a Rust user, I feel like one of those old Apple users where like when I want to write something, it's just when it compiles, I know it's just going to work. And, then it's just a question of like, you know, uh, programmer logic. Like when I'm writing my crawler, the only issues I run into are my own errors in logic of
Right.
like, okay, I want to turn this into that when this happens. And it's like, oh, actually, I forgot that I need to check for whether it's in some state first. Like, I don't have to worry about the language um, having some bug of like a type conversion, like in Python, where it happens in the background. And this type converted to that type, and that screwed up my code because I didn't realize that I was relying on, the it being a certain way, and it's no longer that because the type change happened uh, invisibly, where you have to like actually do it manually in Rust, and you have to really think about it. But it's not hard. Like it's really easy to go from one type to another in Rust. But it's like, yeah, it's just that quiet confidence when I release my code and it's like it's gonna work. That's like forget about like I don't know, trying to convince someone and starting to argue with them about like how Rust is better than C because of speed. It's like really, like you will never in your career probably ever have to get close to that speed. And if you are, then you're writing something like way too simple, or you're like a genius working for a database implementation,
For
like a
for
brand new database implementation, or some game, like where you're writing a game engine. You're not even making a game, you're writing a game engine. You're a freaking genius. So, like, for you to learn Rust, it's like you do that on some evening. Like, you just like do it on a quiet evening.
Mhm.
You're a genius.
Well, it wasn't so much about learning Rust. It was just, So for the record, this was about Arduino,
Oh, yeah.
programming for an Arduino, and they apparently had tried it before, and it was a pretty miserable experience trying to do it in Rust. So that was
Well, and that's where I would say, like, definitely the weakness of Rust today is that it's a new language and it doesn't have a lot of support in a lot of esoteric runtimes.
Mhm.
Like Arduino, you know, what's the, I don't know, at some point I kind of think about like, what's the right tool for the job? Like, you don't have to do everything in Rust also.
Yeah. I mean, he was saying he was just trying it out, and that's
Yeah.
what he decided to try it with, and since then that experience kind of soured his.
But that's like, hey, I needed to hammer this nail in, and I really like this screwdriver, so I'm gonna nail that nail in with this screwdriver.
Yeah,
And I tried it, and it was like it wasn't pleasant.
like the thing is, Rust markets itself as a systems programming language, so people get the
Sure.
impression that you can just use it.
Yeah.
Should be able to just use it for like any embedded systems project, whether it
But
be Arduino or like this stupid board that I have or
sure.
whatever, right? Like
Yeah.
that's kind of the impression that it gives, and so when people try it and then they have that experience with the Arduino, then like that
I feel like that's more a fundamental misunderstanding with definition of systems programming language. Rather, that's more of them attributing a certain like um, behaviors or certain like uh, support. Like they're kind of like when they think systems programming, it
uh-huh.
sounds to me like they're thinking C, and then they automatically think that everything that is systems programming should automatically be able to support everything C does. And it's like, dude, C has been around like forever. It's been around forever. It was around before like computers could do cool stuff, and it was like the best language at the time, and that's why like it supports everything now, because it's been around since that thing first was invented. And at that time when that thing was invented, the best language was C, and so everything was written in C. But like it's like the quote you had from the Twitter, and the guy said, if you're writing any new stuff, you should use Rust. And it's like, yeah, you're totally right. That's an awesome choice for any new stuff. If you want to work with old stuff, probably best to go with, like, it depends how old, right? If it's like if you're working with hardware from the 80s, or you know, then yeah, maybe go to the language of that heyday.
So you're saying if you want to write code for Arduino, just use C.
Is C the go-to language for Arduino, or is it Python, or what is it?
I have no idea. I
I
have,
think
and
I,
that's really C. I mean,
I kind of feel like for, I don't know, a lot of them I feel like are Python.
really?
Yeah,
Huh.
yeah.
I didn't know that.
Because like, the whole idea behind Arduino and all those ones is they're trying to keep it like really approachable. Like it's supposed to be for kids, not supposed to be like for super high-end developers. Maybe I'm thinking of like Raspberry Pi or. But yeah. Anyway, that's like, I'm gonna stop. I need to stop ranting.
It's okay. I could listen to you all day, honestly.
Oh, thank you. You're too kind. You're far too kind.
I feel like I'm learning a lot from you, especially about like the history of
Oh man.
systems and software. Yeah. I'm sorry. I'm just reading this post from Michael.
Hey, guys, I'm gonna probably wrap it up because I just realized I looked at the time. It's 7:30. Hey, Jay, I wanted to thank you for your contributions. It's really awesome to get your perspective. Um, I really appreciate your historical perspective, especially. Um, I don't encounter too many people that
Yeah.
kind of go back to that, and that's really awesome.
50 years, okay?
Yeah, no, that's
Wow.
like he's totally right. Like back then things were simple, and
I had to take it as a big compliment. Thank you.
No problem.
and Michael, thank you for your contribution, pointing me at Tokayo blocking. I had seen it before, but it's nice to have another person point me at it so that I know I'm not crazy to think that that might be kind of in the direction of a solution for the problem I stated earlier.
Yeah, I also wanted to ask about that Clippy lint about the thing, but
Oh, so I sent a link in the messages, and if I may, that's something I encountered while writing code, not specifically with new, but um, in Rust, I find there's a like a style
yeah.
where anytime you're writing a function that returns a result, you need to write the function as try. So you do, instead of new, you write try new, so that then the consumer of that function will know just by seeing the function name that that's going to return result.
But this lint says that it's okay as long as it contains self.
Yeah, and that's kind of, I feel like they maybe relaxed it. They maybe like relaxed the, which is like, okay,
I think it just makes sense because I mean,
yeah.
smart
I mean, most code I always want to write with result.
yeah. I don't know. Anyway, I don't think it's like a super big deal or anything. We should
No.
probably still go.
Yeah. Yeah.
Yeah. Thank you all for coming.
Thanks, guys.
There'll be talks coming. Thank you, Roman. And yeah, if anyone wants to help, we're actually organize the meetups. We do have open positions, so if you're interested, just let me know, and yeah, you can help us out and help keep the meetups alive. But yeah, I'll let everybody go now. So once again, Thank you all.
Thank you.
Thanks all.
Good night.
Bye.